Okay, so you remember from geometry that when you construct triangles, that you label all of the angles with capital letters, and you label the sides opposite those angles with lowercase letters. And they've got to match each other. So side B is across from angle B, and side A is across from angle A, and so forth and so on. Okay, so what we've given you here is we've given you a triangle. You know the length of side A and the length of side B, and you theoretically know that because those were the two that were labeled. C is unlabeled because we don't know it yet. Okay, and that's because you may not know everything there is to know about that triangle. But any triangle that I give you, you can take it and orient it. Let's say I gave you a triangle that looked like this. You can take it and you can rotate it and make it look like this, or however you want to orient it. So it doesn't, you can always take the picture and redraw it so that one side is flat as your base. And that's essentially what I've done here, is I've been given a triangle and I've drawn it in such a way that one of the sides is flat to make it the base of the triangle. Okay, and so if I want to find the area of this triangle, I wouldn't theoretically know the base because I chose one of the sides and made it the base. And I would need to drop an altitude down, which means a line segment from this angle perpendicular straight down to the base. And that would be the height of my triangle. And I would need to know what that height is so that I could find the area of my triangle. Because the area formula, as you know it, is 1/2 base times height. Right? So we would, theoretically, we would know what the base is, but we would not know what the height is. But by dropping this altitude down right here, we have taken our big triangle and divided it up into two small right triangles. Okay? And so theoretically, what we would be able to do is if we know this side and we're trying to find this side, this angle C is one of the angles of our original triangle, because of course angle B is not the same. Angle B has just been chopped by that altitude, and we're not even dealing with angle A, it's way over here. So angle C is from our original triangle, side A is from our original triangle, and we could find H, the height of our original triangle. Okay, and so the trig ratio that we would use would be sine, because sine of angle C would be the side that's opposite from C, which would be that height we're looking for, over the hypotenuse of this little right triangle that I've created, which is A. And so if I was trying to solve for the H, the side H, I would simply take this A and multiply it up to the other side. So I would have A times sine of angle C is equal to the height of my triangle. So what I'm able to do then is, so I take my original area formula, 1/2 base, which is side B of my triangle, and then I can take this and I can substitute it right in there for H. It's a formula that would calculate what the height of my triangle is, which is A times the sine of angle C. And so what I've come up with is I've come up with a different formula for my area of my triangle. Instead of 1/2 base times height, what I ended up with was 1/2 times side A times side B times sine of angle C. Now the reason that there's two other equivalents to it is because one other thing you may remember from geometry is that these triangles that we're going to be working with, you're going to draw them, or you're going to be given the picture for them, and you're going to choose the names of the sides. And you're going to choose where they go. I mean, this could have been angle A for all we know. And this could have been C. I mean, so we get to choose how we name them. So what's really important to notice instead is don't get hung up on the names. Get hung up on the pattern. Okay? So what you notice is that if I knew side A and side B, then I would need to know what angle C is. And so let's say that I had known side B and side C instead? Well, the angle that's in between, let me erase this. If I know side B here and side C here, the angle that's in between them is angle A, and that wouldn't be the angle that I needed to know. And so it would be sine of angle A. And the final version says that if it was side A and side C that we knew instead, then we would need to do sine of angle B. Okay, and they all have that same pattern, and that pattern is definitely the most important part, because what if we were dealing with triangle PQR? Okay, not all of our triangles are going to be named ABC. And the pattern says to do 1/2 times one side times a second side times sine of the included angle. And I'm going to run out of room, so I'm going to... And what it means to be the included angle, it means to be the angle in between the two sides. So let's say I knew I was doing triangle PQR, which we actually are going to do. Let's say that I knew side P and side Q. Then the angle I would need to know would be angle R. And in this unit, the unit that we call solving triangles, it really is the best idea to draw a picture for every situation that you can. Okay? So what I've been given here in this first problem is it just says two sides of a triangle have lengths 7 and 4. The angle between the sides measures 73 degrees. So, of course, this is going to be another unit where you need to make sure you check the mode of your calculator frequently. Okay, but all we have to do is just plug the numbers in. We can draw a picture if we want to, but remember the pattern, just 1/2 times one side, which is 7, times the second side, which is 4, times sine of the angle in between, which we were outright told was 73 degrees. And so the area of that triangle, which in this unit, sometimes the books also call that K instead of A for area. Just plug it in your calculator. You're going to have a calculator for it, because you can't do sine of 73 degrees without it. And so when you type it in your calculator, you would get 13.39. And then whenever you're given units on your sides, you would need to make sure you attach the corresponding units for the area. If our sides are in centimeters, our area would be square centimeters. Okay, and that's it. That's all there would be to finding that area. Okay, now as always, every equation we give you, we work it forwards and backwards. So if I've got triangle PQR, okay, and I know side P and side Q, I need to find all of the possible measures of angle R. And so my area formula says K is 1/2. In this case, I know side P and side Q, which means I would need to know angle R, which would be the angle in between them. Okay, and this time I know my area is 15. I know side P is 5, and I know side Q is 10. And I'm trying to find all the possible measurements for angle R. Okay, so I'm going to simplify the right side just a little bit, just to avoid arithmetic mistakes. 1/2 times 5 times 10 is 25. Okay, and then I divide both sides by 25, and I get 0.6, or you could write it as 6/10 or 3/5, and that's equal to sine of angle R. And we're still going to need a calculator. You're going to have to do inverse sine, so angle R is inverse sine of 0.6. Now when you type that in your calculator, remember your calculator will only give you one answer. We're just going to say it's 36.9 degrees, because we usually round to one decimal place. But that's not the only answer. Now in the previous units when we were solving, we treated everything like it was 4 quadrants, potential unit circle, look in all 4 locations for your answer. And our calculator just gave us this answer, 36.9 degrees. But we know sine, it would also be positive 0.6 over here with a 36.9 degree reference angle. And so that angle would be 143.1 degrees. Okay, now we also need to understand how that works or how that plays into this unit. In this unit, everything is very geometric. And we know that there are 180 degrees inside of each triangle. So angle R could be an angle inside of a triangle when it's 36.9, or angle R could still fit inside a triangle if it was 143.1. We don't know what angle R is. And you're going to see that situation here in just a couple days again. It's called the ambiguous case. And the reason it's talking about it is because we could have a triangle that looks like this, where this is the 5 and this is the 10. Or we could have a triangle that looks like this, where this is the 5 and this is the 10. Okay, and we were trying to figure out what this angle right here was in both cases. So there are two possible situations that occur. Okay, so when you know two sides and an included angle, you can find the area. The other way you can find the area is called Hero's formula. In Hero's formula, in our classes, we offer a little bit of extra credit again, just because it involves a lot of simplifying radicals, and it's going to be a skill that's handy later on in the year. So what Hero's formula allows you to do is find the area of a triangle when you know the three sides. Okay, so Hero's formula says that you're going to do the square root of four numbers multiplied together. The first number is S, which is the semi-perimeter. And I want you to remember that the prefix semi means half, so a semicircle is half a circle, semi-perimeter is half the perimeter. Then you do S minus the first side, then you do S minus the second side, and then you do S minus the third side. And you multiply all those numbers together and then take the square root. So I'm going to show you how to do it with an exact answer, and I'm going to show you how to obviously just set it up to do it in your calculator. So it's one of those where it's, you know, the full credit answer versus the extra credit answer. Okay, so the first thing that we want to do is, we've been told triangle JDH has sides of 5, 7, and 11. So the first thing I need to do is find S, find the semi-perimeter. Okay, so just half of my perimeter, and my perimeter would be 5 plus 7 plus 11. And so my semi-perimeter would be 23 halves. Now you can write it as a decimal, but you don't want to work with it as a decimal if you're going for that extra credit. So I'm going to do it both ways. I'm going to do K. Okay, and they don't use A, I think mostly just because A also stands for a lot of the angles of our triangles, and so they wanted to use something different. And I'm going to do the square root of. So the first number that goes in there is S, which is 23 halves. And then I'm going to take that S and I'm going to subtract each of my three sides. So I would do 23 halves minus the first side, which was 5. Then I would do 23 halves minus the second side, which was 7. And then I would do 23 halves minus the third side, which was 11. And what I'm going to do in all three of those instances is I'm going to rewrite them with a denominator of 2. So I'm going to rewrite this as 10 over 2. I'm going to rewrite this as 14 over 2. And this is 22 over 2. And so now I can begin the simplifying. So I have 23 halves, of course, here. Up in the first set of parentheses, I have 23 halves minus 10 halves, which is 13 halves. The second set of parentheses gives me 9 halves. And the final set of parentheses gives me 1 half. Now here's where things are going to look a little weird. I'm going to do things on purpose in this order, okay? So, on top, I'm going to write the numbers out like they're multiplying, so 23 times 13 times 9, and I don't have to do the 1, obviously, but in the denominator, I'm actually going to multiply all four numbers together. So 2 times 2 times 2 times 2 is 16. And the reason I'm going to do that is because in this instance, because these denominators will always be 2's, I always end up with 16 in the denominator, which has a perfect square root. Okay, so what I'm doing is I'm leaving this written as 23 times 13 times 9, and I'm going to go ahead and take the square root of the denominator, which is 4. And the reason that I did not multiply all the numbers in the numerator together is because trying to pull out the factors that have perfect square roots gets exponentially harder if I actually multiplied 23 times 13 times 9. Okay, but in this form right here, I see 23. It has no factors that have perfect square roots to pull out. Same thing with the 13, but the 9 is a perfect square, and I'm going to go ahead and pull it out and take its square root, which makes it become a 3. The 23 and the 13 stay inside. They don't have perfect square roots. They don't have any factors that are. And so my last step then for that extra credit answer would be to just multiply the 23 and the 13 together, and I would get 299. And it's all over 4. This is what we would consider the extra credit answer. Okay? Now, if you don't care about extra credit, if all you are going for is just get it right, turn it in, be done with it. Remember that this unit requires calculators. And so what you would do instead is you would just take this 11.5 right here, and you would do the 11.5 for your S, 11.5 minus 5, which was this first parentheses right here, is just 6.5. Then you would do the 11.5 minus 7, which is 4.5. And then you would do the 11.5 minus 11, which is just 0.5. And you would just type it in your calculator. And that's it. I mean, literally, just type it in your calculator and you get an approximate answer of 12.9, I think it's 97. Okay, let me check that real quick. Yeah. And then it would still be centimeters squared, because we knew our sides were in centimeters. Okay, so what I would recommend you do is do both. I would recommend that you do the extra credit answer, but also type it in your calculator and get the decimal answer. It's a number one, you can use it to check this. You can type this extra credit answer into your calculator and show that it gives you the same answer, or you can. So you want to make sure that you give me the full credit answer right here as a decimal, because if you happen to make a mistake when you're trying to do the extra credit, but if the only answer you give me is the extra credit, then you're not only not earning the extra credit, you're also losing some of the full credit. So do both, please. And that way you can check your answer and make sure you get your full credit plus potentially the extra credit.